Hello students, good morning. I hope all are doing good, enjoying. Once again, very warm welcome for today's session. Okay, I hope you are learning concepts in a proper manner and studying good and following the lectures in a better manner. Once again, I'm very happy to see you all of you guys into the class. Okay, I hope all are fine. Good morning. If you have attended the class, please just reply. Reply can be any manner. Hi or good morning. You can tap the like button also so that I'll come to know that you people have joined. Okay. Shall we start the class? I hope all of you have attended the class. Hi. Okay, please reply quickly so that I'll start the class. So how many of you have attended the last class? What we have studied in the last class? In last class, we have mainly written the electronic configuration of elements. I hope from 1 to 30. And we have a special attention on the configurations of chromium and copper. We have discussed chromium and copper electronic configuration is peculiar, and the electronic configuration what we have expected is different from the actual electronic configuration. There we have explained some important parameters to support the electronic configurations of chromium and copper. So chromium electronic configuration is actually 4s1 and 3d5. It is not 4s2 3d4. And electronic configuration of copper is 4s1 3d10, but it is not 4s2 3d9. I have given the supporting explanation to explain the electronic configurations of chromium and copper. And the rest, I have given electronic configuration in terms of orbital notation and with box representation, and even I represented with number method also. And we discussed the division of the number of electrons into K shell, L shell, M shell, N shell, and so on. Fine? Okay? I hope all are there in the class. Students, please respond if you are following the class, if I am audible and visible. Shall we start the class? Today we will be continuing electronic configuration of some other elements and different possibilities. Okay, in last class we have left with the electronic configuration of iron, and we need to continue the electronic configuration of Fe plus 2. Fe plus 2 electronic configuration. What is electronic configuration of Fe plus 2? Okay, so Fe atomic number is 26. It means it contains 26 electrons. Write electronic configuration of iron along with me. 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6, 4s2. Now we need to write the electronic configuration of Fe plus 2. If I am converting Fe into Fe plus 2 or Fe2 plus, you need to remove 2 electrons. Fine. Majority of the students will try to remove the electrons from 3D, but it is not actually correct. As I explained in last class itself, if you are having, let's say, 4 orbits for a given element, this last orbit or last shell is called as valence shell or outermost shell. Try to recollect the points which I have mentioned in the last class. Okay? Fine? Okay. So valence shell or outermost shell. If you take the electronic configuration of iron, let's say we have 4s2 in the 4th orbit, 3s2, 3p6, 3d6 into the 3rd orbit, 2s2, 2p6 in 2nd orbit, and in the 1st orbit we have 1s2. Okay. When you are removing electrons from an element, you are supposed to remove from the outermost shell. Therefore, we have to remove electrons from 4s2, rather removing electrons from 3d. You are not supposed to remove the electrons from 3d first. You must remove electrons from 4s. After the removal of electrons from 4s, if any number of electrons you are to remove, you have to remove then from 3d6. First you have to remove electrons from 4s followed by 3d. Now what would be the electronic configuration of Fe plus 2? Here I am writing electronic configuration of Fe plus 2. It is 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. 4s has 0 since we have removed 2 electrons from 4s. Immediately my next question to you is, can you identify the total number of unpaired electrons in Fe plus 2? My question to you is, identify the total number of unpaired electrons in Fe plus 2. If you look at the electronic configuration in Fe plus 2, 1s is filled with electrons. There is no unpaired electron because this orbital is filled with 2 electrons, and 2s also filled with electrons, completely filled with electrons. 2p also you do not have any single electron. Yes, 3s do not have any single electron. 3p do not has any single electron. If at all, if you find these single electrons, only you must find in 3d6. My question to you is, you have to find out number of unpaired electrons. What do you mean by unpaired electrons? Unpaired electrons means, if you observe an orbital, the orbital with singly occupied electron, orbital with singly occupied electron is called as unpaired electron. Then try to find out the total number of unpaired electrons in Fe plus 2. Can you find out? Can you find out and tell me the answer? Students, am I audible and visible to you? I am not able to see your responses. Are you there in the class? Are you following the class? Response please. How many unpaired electrons are present in Fe plus 2? If I ask you a question in this way, you need to check out the orbitals and all the subshells, check out properly. If you find in any subshell or in any orbital with singly occupied electron, the orbital with singly occupied electron is considered to be unpaired electron. Let's try to find out the number of unpaired electrons in 3D subshell. Since 3D subshell is incompletely filled, you can identify number of electrons, unpaired electrons in only 3D subshell. According to Hund's rule, as I mentioned yesterday, when you are trying to fill the electrons into degenerate orbitals, always imagine Hund's uncle is along with us with a stick, whether you are following his rule or not. After occupancy of electron in each degenerate orbital, then you must start pairing. Okay, 3D 6. If you observe carefully, here this is filled, it is not singly occupied. We have in total how many singly occupied electrons here? There are totally 4 unpaired electrons. So number of unpaired electrons in Fe plus 2 is 4. Is this point clear? Is this point clear? Is this point clear? Is this point clear? Okay. Now I'll give a question, simple question. There you need to find out the number of unpaired electrons in a given species. Okay. Shall we work on it? Is this point clear? We have written electronic configuration of Fe, and also I have given electronic configuration of Fe plus 2, and I asked you a question to predict the total number of unpaired electrons in Fe plus 2. We got the value as 4. Now my next question to you is, okay, which of the following species, which of the following pair otherwise pair has same number of unpaired electrons? This is very important question. In fact, such kind of questions can be expected for NEET examination. I think somehow or other this kind of question was given for NEET previous year questions. Okay, here I am presenting the options. You need to find out the correct option. Okay, so my options to you is CO plus 2 and Ni plus 2. Option B. Option B. Fe plus 2 and Mn plus 2. Option C. Option C. Cr plus 2 and V plus 2. And option D. Mn plus 2 and Fe plus 3. Answers please. Whoever responds quickly to this question, I'll try to give a chocolate when you are coming for online classes, offline classes. Okay. So this is kind of chocolate question. Try to answer this question quickly. Try to answer this question quickly. It is very easy question. You people have to write the electronic configuration first. And after writing electronic configuration, try to focus on 3D subshell and try to identify number of electrons in 3D subshell. Okay, can you try and tell me the answer quickly? Try and tell me the answer quickly. Try to give the answer for this question. First of all, you need to write the electronic configuration of elements. Okay, then you need to convert that into ion. First, let me start with cobalt. What is atomic number of cobalt? 27. And write the electronic configuration. Here in a short way, I will try to write argon core and 3D 7 4s2. Am I right? Fine. Next. If I am trying to convert cobalt into cobalt plus 2, you have to remove the electrons first from 4s, then followed by removal of electrons into 3D. Now 2 electrons I have removed from 4s. Now try to focus on 3D subshell. since 3D subshell is looking like incompletely filled, you can expect number of unpaired electrons in incompletely filled subshell only. Okay, 5 electrons were already occupied, 6th electron, and this is 7th electron. So how many unpaired electrons are present in CO plus 2? It is 3 unpaired electrons. I have 3 unpaired electrons. As I mentioned already, unpaired electron is the one which is observed in an orbital with singly occupied. So singly occupied electron is considered as unpaired electron. Okay, it is from option A. The second one I am trying to write, nickel. Electronic configuration of nickel is argon 3d 8 4s 2. As we know, atomic number of nickel is 28. It is very easy to recollect the electronic configuration. 2 here represents the number of electrons in 4s, and here 8 represents the number of electrons in 3d. Mostly it suits for most of the elements except for chromium and copper. Fine? Okay. Now try to convert nickel into Ni plus 2. Ni plus 2. If you convert nickel into Ni plus 2, the electronic configuration will be converted into 3d8 4s0. Now try to focus on 3d8 since it looks like incompletely filled. That is why we are focusing on 3d configuration. 1, 2, 3, 4, 5, 6, 7 and 8. So how many unpaired electrons are present in Ni plus 2? It is equals to 2. 2 unpaired electrons. I hope you are following. Next, how many unpaired electrons are present in Fe plus 2? If you keep on calculating, Fe plus 2 we have got already. Fe plus 2 has 4 unpaired electrons. Let's try to calculate for manganese. So manganese electronic configuration is argon 3d 5 4s2. If I am converting Mn into Mn plus 2, remove electrons first from 4s. Now it becomes, now how many unpaired electrons are present in Mn plus 2? Let's try to write 3d5 with box representation. If I write with box representation, Hund's uncle is near to us, he is with the stick. Don't try to pair up initially. So total number of unpaired electrons here are 5 unpaired electrons. Done? Okay. No, this is not the option. This is not the option. If you try to find out what would be the correct answer for this question. Anyone please? What is the correct answer for this question? Anyone got the answer? In the same way, if you are trying to convert Mn into Mn plus 2 here and Fe into Fe plus 3, you will get to know the total number of unpaired electrons in Fe plus 3 also. So far we have concluded the total number of unpaired electrons in Mn plus 2 is 5. Let's try to work on Fe plus 3 also. Fe electronic configuration is argon 3d 6 and 4s2. And if I am converting Fe into Fe3 plus, you need to remove 3 electrons. As I mentioned already, you must remove the electrons first from 4s, then move on to 3d. Now here I have to remove 2 electrons from 4s. One more electron I supposed to remove from 3d. Now the configuration becomes 3d5. Therefore, even in Fe plus 3 also, total number of unpaired electrons are 5. So therefore, the pair of species which contains same number of unpaired electrons is option D. I hope you are getting the answer. Have you got the answer? The correct answer for this question is Mn plus 2 and Fe plus 3. It is simple. If you can guess, if you can observe the options carefully, these elements are subsequent elements. After cobalt, nickel comes plus 2 and plus 2. Okay, you don't expect the difference you don't expect the similarity in number of unpaired electrons. There will be definitely difference in number of unpaired electrons. Again here Mn and Fe both are in +2 oxidation state. Therefore, you don't expect the similarity of number of unpaired electrons over here also. In the same manner, vanadium, after vanadium, and what will be coming? Chromium. Then you don't expect the similarity in number of unpaired electrons for this pair also. If you observe carefully, Mn +2, you have removed 2 electrons from Mn and you have removed 3 electrons from Fe. You can expect the similarity in number of unpaired electrons only from fourth option. Okay? Right? One more question to you is question number 2. Which of the following pair? This is very simple question. Which of the following pair is having no unpaired electrons? No unpaired electrons. You need to identify the pair with 0 unpaired electrons or no unpaired electrons. Option A. Okay. We have solved few things. Sc +3 and titanium +2 and option B. Okay. Titanium +3 and vanadium +2. C. Okay. Zn +2 and Ni +2 and D. Cu plus and Zn +2. Anyone please? Which is right answer for this question? Without even using pen paper, you can guess the answer. Okay. So what is right answer for this question? What is right answer for this question? What is right answer for this question? Anyone? Let's start from backside. Okay. So in the previous question, we tried to check from A to D. Now I'll try to check out from D to A. Okay. So I hope you got the answer. I guess you got the answer. You got the answer. What is right answer for this question? What is right answer for this question? Okay. I hope you are able to write electronic configuration and you are able to convert the given electronic configuration into ionic form. Okay. When you are converting Sc into Sc3 plus, you have to remove 3 electrons. I mentioned first you need to remove electrons from 4s, then followed by 3d if any left electrons. Okay. Now try to convert Cu. What is electronic configuration of Cu? Atomic number of Cu is 29. We know the electronic configuration of copper. It is argon 3d 10 4s. As I explained in last class, whenever you are writing electronic configuration of copper, you must write it as 4s1 and 3d 10. I need to convert Cu into Cu plus. That is, you have to remove one electron from copper. You should remove electrons first from 4s. Now 4s becomes 0. Now if you observe carefully 3d10, it is completely filled. 0 unpaired electrons or no unpaired electrons. Next. And Zn +2. So what is electronic configuration of Zn? Zn is argon 3d 10 and 4s2. Okay. Now if you are converting Zn into Zn +2, remove electrons from 4s. If you remove electrons from 4s and the 3d only left with 10 electrons. Again, D subshell is completely filled. You don't expect any unpaired electrons. So here also no unpaired electrons. Students, believe me, if you are able to find out unpaired electrons, by using this method, you can be able to solve a NEET expected question. So what I am trying to say, you will study a chapter named as complex compounds or coordination compounds in your 12th course, and one more chapter which is named as transition elements. In transition elements and in coordination compounds also, you must deal with such kind of examples. There are two important properties which depends on number of unpaired electrons. One is identification of color expected by the given sample, and second one is identification of magnetic nature of a given sample. If you are able to identify the number of unpaired electrons in a given ion or in a given species, you can predict the information about color, and you will also be able to predict the information about magnetic nature of a given sample. So working this kind of question is very important for your future classes. After writing electronic configuration of elements, then you must work on such kind of questions. These questions are very important for your future study. Okay, so with this we will try to close this question. So what is right answer for this question? I think we have started from option D itself. Option D is the correct answer for this question, because both CO plus and Zn plus 2 do not contains any unpaired electrons. Let's try to cross check any other option. Let's try to cross check scandium. Scandium with atomic number 21, its configuration is argon 3D 1 4s2, since its atomic number is 21. Try to convert scandium into scandium plus 3. If you are converting scandium into scandium plus 3, it means you have to remove 3 electrons out of scandium. If you remove 3 electrons out of scandium, now the scandium plus 3 configuration becomes 3d0 4s0. There is no unpaired electron here. Okay, you need to check out both species, no unpaired electron, because our answer must be the option in which both ions must not be having any unpaired electrons. Now try to go for titanium. Titanium electronic configuration is argon 3d2 4s2, and try to remove 2 electrons out of titanium. If you remove 2 electrons out of titanium, now the configuration becomes 3d2 4s0. Now we have got 2 unpaired electrons, so this is not the right answer for us. I hope such kind of questions you can be able to solve. Okay, so with this we are trying to close this question. Okay, let's move on to the next page. Okay, now students, before going to start the new topic, so I wanted to brief out few things related to elements. Okay, with this we have concluded electronic configuration of elements. I have given from 1 to 30. Okay, some exceptional configurations also we have discussed, and afterwards we have discussed certain important questions of identification of number of unpaired electrons in a given species. Okay, if you wanted to try the electronic configuration of elements after 30, that is your wish. Okay, in our bridge course it was given for discussion about electronic configuration of elements from 1 to 30. You need to know the basics or inputs in order to write the electronic configuration of elements. I have given the important inputs and concepts and fundamentals or basics to write the electronic configuration. I hope you will be able to write the electronic configuration for any element with the rules which I have given in previous classes. Okay, so before going to start the next topic, I wanted to give a brief review on periodic table. Review of periodic table includes the identification of metals, identification of non-metals, identification of metallites, identification of valence electrons, etc. Okay, shall we start? Okay. Okay. So here periodic table of elements, here many things are there. In future when you are coming for offline classes, we will try to explain all the stuff, okay, wherever it is required. Now today I wanted to hear atomic structure related things are there. Can you observe? I think color needs to be changed, okay. So just leave this one. Our intention is to work on periodic table. I hope you are able to see the periodic table. I hope it is visible. Okay. Fine. Good. It's looks like nice. Students, my dear students, with periodic table we can elaborate many things. Periodic table is in fact very important chapter in first year course. Okay. Many important properties, many important conclusions can be derived from periodic table. If you observe carefully here, the vertical columns. So this is one vertical column, vertical columns, vertical columns. In total, how many vertical columns are present in this periodic table? How many vertical columns are present in this periodic table? Anyone, 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 anyone? How many vertical columns are there in the periodic table? In total, 18 vertical columns are present. How many horizontal rows are present in this periodic table? 1, 2, 3, 4, 5, 6, 7, 8. In total, this is here, from here it starts. Okay, sorry. 1, 2, 3, 4, 5, 6, 7. In total, we have how many periods? 7 periods. So these horizontal rows are called as periods and vertical columns are called as groups. Group number 1, group number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. In total there are 18 groups. These vertical columns are called as groups. Okay, and horizontal rows are called as periods. In total 7 periods we have and 18 groups we have. Actually this is a old convention of representing representation of 1A, 2A, etc. Okay, according to IUPSC conventional latest convention, we can represent the groups with numbers from 1 to 18. Okay, if you observe carefully, listen carefully. If you observe here, first two groups are considered to be S block, since the last electron of these elements enters into S orbital or S subshell. So this block is called as S block. And if you observe carefully, groups from third A, I mean 13, I'll write. Let me make it short. Okay, look at carefully. I'll write few conclusions. These are considered to be, what are these? Tell me, students. I told already. Okay, no issues. I'll write here. So 1 to 7, these are called as periods. In total, how many periods we have? 7. Periods are nothing but horizontal rows. Next, if you observe carefully, here from 1 and 2 and then 3 and so on up to here 12 and 13 and so on up to 18. These are vertical columns. So vertical columns are called as groups. We have mnemonics to remember or memorize these elements. We have many mnemonics. I'll try to give. Okay, look at carefully. This first two groups belongs to not this one. Okay, 1A, 2A. I try to write here. I have written 1, 2. These are considered to be from S block elements. Next, groups from 3 to 12 are considered to be D block elements, and groups from 13th to 18 are considered to be P block. Okay, the bottom of the periodic table which we have represented here, this is called as F block. This is not actually the place of F block. F block supposed to be under this group, third B group. Here I have mentioned lanthanides and actinides. This lanthanides original place is third B group. So these are lanthanides and this is lanthanoid and these are actinoids. Okay, I think here. Okay, sorry. Okay, so I hope these points are clear. So let me wind up once. So here 1, 2, 3, 4, 5, 6, 7. These are considered to be horizontal rows. Horizontal rows are called as periods and we have in total 7 periods. Okay, and vertical columns which are labeled as 1, 2, 3, 4 up to 18 are called as groups. In total we have 18 groups in the whole periodic table. And there is other classification of elements into SPDF. First two groups, groups 1 to 2, these two groups are considered as S block, and groups from, let's say here 3rd A to 7th A and 0 or else 13th group or else 13th group. Okay na? 13th group is considered to be 13th to 18 is considered to be 13th to 18 is considered to be P block, and the middle from right from 3rd B up to 2B, this is between 12 and 3 to 12, this block is called as D block. At the bottom of the periodic table the entire block is considered to be F block. Where is the actual home or place of this F block? It is under 3rd B. All these details we will also study in upcoming classes and offline classes. Okay, what I wanted to mention here, look at carefully. I need these points. I need these points to be learned. Okay, if you observe carefully, these gases are called as noble gases. As everyone knows, zero group elements are noble gases or inert gases or aerogens, etc. Many names are there. These group elements are called as halogens. These group elements are called as halogens. Okay na? Halogens. And this group is called as halogens. This group is called as 16th group or oxygen family or many other names, chalcogens. These group elements can also be called as nitrogens, boron family, carbon family. Look at carefully, non-metals. Here they have labeled non-metals with this color and metals with this color and transition metals with this color. Okay, my dear students, if you observe carefully, almost majority of the portion of this periodic table includes metals. Let me write the metals in this way. Okay, S block, entire S block, comma, D block, comma, F block. So all these three blocks are containing metals. Okay, here hydrogen is a bit different story. We will work on hydrogen in some other class. Okay, so hydrogen, if you exclude, hydrogen place was not certain so far. So S block and D block and F block, all these elements are considered to be metals. S block, entire S block and entire D block and entire F block is considered to be metals. Okay, hydrogen I am not including. Hydrogen story is different. Okay na? Next, when you are talking about P block, P block there is unity in diversity. In P block we have metals, non-metals and even metalloids also. When you are considering this one, silicon, germanium, I will try to mention here. Okay, here boron is A non-metal only, boron, carbon, nitrogen, oxygen, all the stuff which are represented with the color, green color, okay. So all these are considered to be non-metals. Of course, germanium is actually a metalloid. I'll give you the list of metalloids. Okay, I'll give you the list of even antimony also. I think they have mentioned under metal, but it is not originally completely metal. It shows metallic properties as well as non-metallic properties. Okay, the color which we have represented here, this is about metals, and the color which we represented like this is non-metals. Green color one is non-metal, and the rest of almost all are metals. Of course, here there is a border. Okay, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. These are considered to be metalloids. I'll write the list of metalloids over here. Metalloids list I am going to write over here. Metalloids I am writing over here. List of metalloids. And non-metals I have mentioned. I need to mention the metalloids. What metalloids are present over here? Silicon, germanium. Am I right? Next, arsenic, antimony, and we have tellurium and polonium, astatine. Of course, some of these one or two elements cannot be strictly considered as metalloids, but they can be expected to show both metallic properties as well as non-metallic properties. Of course, the dominant parameter we need to discuss. Strictly speaking, whenever we are talking about metalloids, first comes into our mind is silicon, germanium, arsenic, antimony, and of course up to tellurium we can work. Polonium and astatine are optional. So predominantly they can be considered to be, polonium is considered to be predominantly metallic. Of course, sometimes it can also show non-metallic nature. That is the reason why I am not including polonium and astatine. So the non-metals I have given with this color, and metalloids list I have given silicon, germanium, arsenic, antimony, and tellurium. You can strictly write. I am repeating one: silicon, germanium, arsenic, antimony, tellurium. The rest, polonium and astatine, are not strictly considered as metalloids. Okay. So try to have a review on the periodic table and try to identify the elements into metals, non-metals, and metalloids. Okay. In next class, we will start a new topic. Before starting the new topic, you need to have a basic understanding about nature of elements. I hope the class is okay. I think you have followed the class and trying to note down something, and you are giving responses too. So try to continue the classes regularly, and whatever you are writing, try to revise them. With this, I wanted to close for today's session. That's all for today's class. Have a nice day. Thank you.